Question 19. Analyze each function for domain, range, continuity, increasing. Okay. So question 19, the cosecant function. Cosecant goes with which of the trig functions? Cosecant goes with? Cosecant does not go with cosine. Sine. So the sine function, we know it's going to do something like this. And that should be enough to kind of get us the idea, because what do we need that sine wave for? Yes, but what do we identify first on any of these reciprocal trig functions? We always identify, after we kind of do a dotted line of the wave of the one we know it goes with, we need the asymptotes. So hopefully you know that there's one there, there's one there, there's one there. Every single time you get another x-intercept of the sine wave, you're hitting another asymptote of the cosecant. Of course, after that point, then you know that you can draw the fake parabola things inside, and you can kind of get the basic idea. Okay, there's the quick sketch, right? So graph the original, and then do your asymptotes, and do the little fake parabola things. That's for cosecant and secant, right? Obviously cotangent, looks a little bit like tangent, except things are flipped over the x-axis, so to speak. Anyway, so domain, we did talk about this, domain and range. Domain would be all reals except, and I should have left myself more room, except what? Multiples of pi, yep, except n pi, where n is an element of the integers. You are correct. And yes, you need to know your notation, as we talked about before, which means the same thing as integer multiples of pi. Range, this is a split range. What is it? Negative infinity. Wow, that is a horrible looking parenthesis. I apologize to all parentheses on the planet. Negative infinity to what? To -1, bracket, union, +1 to infinity. Okay? So those are that's the range. It skips all that stuff between -1 and 1. What about continuity? Is this function continuous? No. It is discontinuous, so it's got what kind of discontinuity points? It's got a lot of infinite discontinuity points. At what? N pi, where n is an element of the integers. Yes. Yeah, those vertical asymptotes are the places where you have to keep picking up your pencil. So it's definitely not continuous. How about increasing or decreasing? Well, this could get kind of complicated. Right? Because as you're moving through the graph from right to left, isn't it increasing for a ways and then decreasing and then decreasing and then increasing? Isn't it jumping back and forth? Besides the fact that you got these asymptotes in the middle. I mean, this section right here is increasing, followed by decreasing. That's decreasing. That's increasing. I probably wouldn't ask you this question on this particular one because it is so broken up. I could even ask you, name an interval where it is increasing. Let's just do that. Name one interval where it's increasing. 0 to 1. Well, folks, everything we got pi over here. Pi over 2, which would be right about smack dab here. Pi over 2 to pi. I'm going to buy that as long as you put the correct boundaries on it. Okay, pi over 2 to pi. What should I be putting on each end? Are you saying parentheses for both?
No, bracket on the pi over 2 and then parentheses over pi.
I will buy the parenthesis on the right. Why can't you put a bracket on? Because at first I was thinking bracket 2. All right. So what's going on right here? Okay, if you're on the roller coaster, okay, coming down, 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 down. What's happening directly right there? Are you going up or going down?
No.
Neither. You are smack dab at the bottom of that little valley, right? There is no increasing or decreasing at that point. That's why it has to be a parenthesis. Okay? But I like the thinking. That was good. Okay, give me one decreasing. Oh, you cheater. 0 to pi over 2. You just copied the other part of the other side of that interval. But I will buy it because it is correct. 0 to pi over 2 would be a decreasing portion of the graph. But yeah, it alternates back and forth. You know, that would be a mess to write out, quite honestly. And I'm sure we could get really cool with our notation, but it would be way more than you would want. Symmetry of the graph. Symmetry of the graph. Does it have even? Is it a reflection symmetric across the y-axis? Can you fold that thing on the y-axis and have it look exactly the same? If that's the truth, okay, here's my y-axis. If I flip this part, then there should be a duplicate one of these sitting right there. And there isn't. So it is not reflection symmetric across the y-axis. So it's not even. Can you rotate the whole thing 180 degrees around the origin and have it look exactly the same? Yes, therefore it's an odd function. Okay? Yes, question. I hope so. Fill that out, and then we'll all wish you good luck. Okay. Oh, by the way, if any of you ever needs to use the restroom and you are not feeling well, I mean, now I don't know if he's tired or if he's sick. He just doesn't look himself. But if you ever are feeling sick to your stomach and you need to use the restroom, just grab the trash can and go. All right? I do not want a kid embarrassed in this school because they're getting sick. Right? Not like there was one freshman several years back and they sent that kid, and I hope it was a sub. They sent that kid all the way to the clinic. Well, you know that nice shiny hallway over there? You know how it is sloped? Yes, yes. And, you know, the liquid moves. It was gross. It was gross. And I felt so bad for that kid. So I was like, okay, always send a kid with a trash can. And yes, folks, I did just record that. All right, now. But I'm serious. Just take the trash can and go. All right? We will find you. I know. I'll be like, whoa, what in the world? No, he just, I don't know if he's just tired. He just kind of looks sick. You know, maybe he's not. But if you ever need that. Okay. Boundedness. Is this bounded above, bounded below, or not bounded at all? Oh, by the way, if you think it's bounded above and below, you would use the word bounded. Not to be confused with eating a lot of cheese. That is a completely different boundedness. Never mind. Older people, when you're bound, you just like, you can't go to the bathroom. When you eat a lot of cheese, man, I'm just saying, it's a bounded joke right there. What do you think? Bounded above, bounded below, bounded completely, or not bounded at all? If you think it's bounded above, you think I can draw a horizontal line across the graph and it never goes over that line. Nope. If you think it's bounded below, you think I can draw a horizontal line and it never goes below that line. Okay, so hopefully you say that it is not bounded at all. Okay. Extrema. Do you have any relative mins or maxes on this graph? Okay, hopefully you see a lot of relative mins and maxes on this graph. Can you name me any relative min? Any relative min? Okay, remember, relative mins and maxes are y values, and they occur at a particular x value. So let's suppose you think a relative minimum occurs right there at the bottom of that little valley. That'd be a good choice, by the way. What is that y value? 1. And it occurs at x equals pi over 2. That is an example of a relative minimum. And of course, it's going to happen. You could continue adding 2 pi to get all those. How about a relative max? Relative max, probably like that one right there. -1 at x equals 3 pi over 2. And yes, there's lots of more of those. We could try to write a formula to find all of them. And I'm sure if you go to the answer sheet and look at the solution, it has some really cool way for you to find all of them. But at the moment, it would take more of your attention to figure that out. End behavior. What's going on? End behavior. This would be really cool if I could just write this as a limit, right? What's the limit as x goes to infinity? Let's see here. Well, you told me that it was, it had one of these things, and then another pi, then it had one of these things, and well, it's just going to keep doing that, isn't it, for a long way? As I keep going this way, I'm going to have another one of these. And what do you think's happening as we continue out to positive infinity? Come on, folks, we're going to go this way, a real long way. Yeah, okay. So remember, a limit is a y value that it gets closer and closer and closer and closer to. It has to be a single one y value that you get closer and closer and closer to. Is there one? No. So there is no limit. So why don't we just write no limit? Or limit does not exist. Kind of like they did in that Mean Girls movie. The limit does not exist. Right? You could write something like that. D&E does not exist. What about the limit as x goes to negative infinity? Hey, good job. You figured out the other side doesn't exist either. Awesome. Those are the end behaviors. What happens at the far right and the far left side of the graph? By the way, is there a trig function out there that you can think of? A trig function that gets closer and closer to a particular value, either positive or negative infinity? I mean, think about a sine wave in your mind, or a cosine wave. I can't think of a single trig function that's getting closer and closer and closer to something. I can think of an inverse trig function. Can you think of an inverse trig function? Cotangent, maybe. I was thinking of just plain old tangent. The tangent inverse function, the one we talked about, this, that one would have a limit on the right and on the left, because one's approaching pi over 2 on the right, the other one's approaching negative pi over 2 on the left. So that's the only thing I can come up with quickly off the top of my head. Any other homework question on 4-5? Yep. 37. Okay, so I'm going to need a calculator for this. Cotangent x, so that would be the same thing as 1 over tangent x equals negative 0.6. Ooh, man. That would mean the tangent of x would be what? Come on, folks. 1 over, or negative 1 over 0.6, not 2 negatives. It wouldn't be 2 negatives. Who in their right mind would put 2 negatives? You can only have 1 negative if you want to keep it negative. So, let's think about this. So you got a tangent graph. You know it's doing something like this. Right? And a little while later, we do another one of those, right? So what is negative 1 over 0.6? That's the same thing as negative 1.6 repeating. So let's see, negative 1.6 repeating, something like that. Okay. And we want to find an answer according to this, which is between 3 pi over 2 and 2 pi. On my graph, where would that be? Is it this one right here that I just circled in red? No, it can't be, right? Because that's going in the negative direction. Is it the second one I circled in red? Okay, because right here's pi over 2, right? And the next one over there is 3 pi over 2. So that's still not it, isn't it? Oh, okay, so I got to come over here. So there's another one that kind of is going off screen here because I didn't leave myself enough room. It must be that one right there. Ding, ding, ding. That one's the one I'm looking for. How do you find this one? I'm not saying that's the right answer, but how do you find it? You can use a machine. Don't be scared of it. For instance, how would you solve the equation at the bottom? How do you get rid of it? Inverse tangent, yes. You got your handy dandy calculator. They won't be in radians. Okay, so let's make sure my calculator is in radian. Yep, and it's still in radian mode. Type it. Tangent inverse. Tangent inverse. What'd you get? Negative 1.03. Let's just go with that for now. Okay? Good enough? What is the distance? What is the distance between 0 and negative 1.03? Does anybody know the distance between 0 and negative 1.03? 1.03, thank you so much. How could I use that information to find this answer right here? How could I use that logic? For instance, that's pi right there. So what's the lavender one I'm circling right there? That's 2 pi, isn't it? How can I use that to find the correct answer? Can't I subtract? And how much should I subtract from 2 pi? Anybody got an idea? How far back should I move? 1.03. All I'm doing is coming backwards 1.03 units. So if you can type 2 pi minus 1.03, I'll bet you get your right answer, 5.25. Could I have graphed this using y1 on my calculator? I don't know. Is that what some of you did? I hope you used your time wisely last week and didn't just blow it all off, because that's going to make for a bad test if that's the case. Where in the world is my camera cord? Yes, my camera cord. I know where the camera is. It's right over here. That ain't it. Oh, come on. Open up the camera part. I said, oh, it came unplugged. Crap, I hate that when that does that. Alright, we'll try again. Now don't come unplugged. Come on. So could we have graphed this? What window should I set my what should I set my window up as? What do you think would be smart? 0 to 3 pi? Sure, that's fine. Now I will tell you 0 to 3 pi is more than I need. But it'll work. And my x scale, let's go pi over 2 just so kids aren't confused. Y min and max? Negative 2 to 2? Sure, that'd be enough. How about we also throw in another line, y equals negative 1.6. You got to give it a few sixes, you know. Okay, which droid is the one we're looking for? Is that one? No, right? That's pi over 2. That's pi. That's 3 pi over 2. It's got to be between these two right here. So it's got to be this one right here. Is there any feature you can use on your calculator, like right above the trace button? Is it what?
There is indeed.
Okay, there is indeed. I did not get that out of what I heard. Okay, but now I've got it. Okay, so calculate intersect, right? Okay, so you're doing the whole, is the first curve the blue one? And you hit the enter button. Yes. Is the second curve the red one? And you hit yes. Then you got to the guess feature. Guess what? If you don't give it some information on the guess part, it's going to pick for you, and you may not be happy. So if you're going to guess, why don't you guess something in this range right here? Something between 3 pi over 2 and 2 pi. Do you know any angles between 3 pi over 2 and 2 pi? Please tell me yes. Get a whole unit circle. 3 pi over 2 down here, right? Somewhere between here and here, right? You got anything over there? Okay, just pick me one. When you do the guess, you got to give it something over here. 11 pi over 6 would work, yes. 7 pi over 4, 5 pi over 3, you know, any of those. Right? Could you also use your cursor and get it close to the one you're looking for and hit the enter button? Yeah. Now, I didn't show you that at first because I want you to use your brain. Some of you just let this machine do everything for you and you don't actually have a good idea of what they're asking for. So you do the calculate intersect feature. First curve is the tangent, yes. Second curve is the line, yes. Now this happens to be conveniently close to the one I want. So when I want to guess, I'm just going to get close and let the magic happen. Okay. Next question on the list you want from anything for 4 or 5? We good on 4 or 5? How about 4 7? Switch over to 4 7. Yep. 49. Somewhere down here. Question 49. Oh, I gotta get off the lavender. It's not my fave. Magenta? I don't know. I don't work for the Crayola Corporation. Maybe I should. If I did, I'd be a security. I'd be security for the Crayola Corporation. Because then they could call me the color guard. Okay. Sorry. Here's my angle theta down here. I'm looking at question 49. I see arc sine x. Arc sine x. Let me write that out a different way. Arc sine. Thanks for paying attention. X over 1. How is that information helping me label 2 of the sides of this triangle? Opposite. Okay, that's opposite. Hypotenuse is what? 1. That's the information I got from the interior part of that problem. Okay, so what are you going to call that bottom leg? The square root of 1 minus x squared. Now, if you don't know how we did that, that's called the Pythagorean theorem, and we just did it real quickly. But if you need it slowed down, you're more than happy or welcome to do that. If you want to call this x and this 1 and call this like a, you could do the a squared plus x squared equals 1 squared. Hopefully you already know that 1 squared is 1. And then you could go through the process of subtracting the x squared and taking a square root. Yes, we just did that pretty quickly. Now they want the tangent. What is the tangent of this? So the tangent of theta is, what'd you say? Yep. Do you think I am so cruel as to make you rationalize that? No, I'm not that cruel. All right, that is good enough for me. That is what I'm looking for. I'm looking for you to make the triangle with the information you've been given, and then to identify the correct trig function that they asked for. Yes. Arc and inverse are the same exact thing. So if this had said sine inverse of x, those would be the exact same things. Okay? Hopefully I said that in the notes, but if I didn't, shame on me. Okay, what else? 4-7. Yep. 45. Okay, question 45. Find a solution to the equation without a calculator. Cosine of cosine inverse of x equals 1/3. What does cosine inverse always spit out? I can't say as I really like this question without a calculator, but cosine inverse always spits out what? It always spits out an angle measurement. Okay, so what's going into a cosine inverse function is an x value, and what's coming out is an angle measurement. Now, where is that angle measurement? Curious if you know. Can you give me any part of the circle that angle measurement would be? Quadrant 1 or 2, right? I did the whole... Did I talk about the comb over joke? My father's hairdo? I mean, that's been his hairdo for a long time. As long as I can remember. Okay? I'll never have that. Okay? So 0 to pi. So this question is really the cosine of theta equals 1/3. The cosine of some angle measurement equals 1/3. Can you tell me what the angle is? Actually, we don't want to know the angle, do we? We want to know what the original x value was. What's the original x value? What's the original x value that would spit out an x value of 1/3? 1/3, thank you very much. They gave you the answer. They gave you the answer. It wasn't as hard as I was thinking it was going to be at first. Give me the x value that gives an x value of 1/3. Yes, the answer was 1/3. Okay, what else? 23. Okay, so sine inverse 1/2. Is that 1/2 an x value, a y value, or a slope? You're saying that's a y value in there? You are correct. All right, so they're giving me a y value of 1/2. Can you see two letters on this particular screen right here that have a y value of 1/2? H and B, right? They have a y value of 1/2. Okay. You better narrow it down. Which one are we talking about? Are we talking about H or B? Because sine inverse only has a range which gives you one of those. What is the range of the inverse sine? It goes from negative pi over 2 to positive pi over 2, including the endpoints. So which one is it, H or B? It's over here at letter B. Now, I don't even care if you know what that angle measurement is for this question. I mean, down deep in my heart, I really do care, because you better know it's pi over 6. But that's not what this question is asking you for. It's asking you for what? They want to know the x value at that location. So even if I didn't know it was pi over 6, which would be heartbreaking for me if you didn't know it was pi over 6. But what is that x value? That is positive radical 3 over 2. Any of those other ones in there? Because those are important questions. Another one of those? Anybody have a fan favorite besides 23, since we just did it? Don't talk to that kid. Okay, what? What? Which one? 29, thank you very much. Okay, cosine pi over 3. Okay. Which letter represents pi over 3? D, thank you. All right, so what are they asking me for here? Cosine. Is that the x value, the y value, or the slope? It's the x value. Do we know what that x value is? Yeah, but the more important question is, can we read it? Oh, gee whiz. I guess the answer is no. Arc sine 1/2. Yes, I know that's the same as 1/2. What's arc sine asking me for? An angle measurement, right? An angle measurement between what and what? Your answer has to be between negative pi over 2 and positive pi over 2. Oops, sorry. Look at that, man. I put parenthesis on the right side. Oh, my goodness. Is that 1/2 there? Is this an x value, a y value, or a slope? That's a y value. So we want a y value of 1/2. And your answer has to be between negative pi over 2 and positive pi over 2. What do we think? I did hear it. Yes. Pi over 6 is correct. You see why it has to be at choice B? Because it has to be on that side of the circle, from negative pi over 2 to pi over 2. Some of you are inspiring a lot of confidence in me for the upcoming test. And some are making me worried. Okay. You have any other questions out of these? Or shall I move forward?
43.
43? Find the solution without a calculator. Okay. So I bet we could divide by 2 on that, and that would give me sine x equals 1/2. Does that agree with everybody's stomach? Are we okay on that one so far? So what are you going to do? How do you get rid of sine? You're going to do the inverse of sine, right? Although we don't have a calculator here, so we're just going to use our brain. I think it would be best if this particular question gave me some more information. Suppose they said something like this. Negative pi over 2 is less than or equal to x, which is less than or equal to pi over 2. What answer would you give me? You should give me pi over 6 right there, because the y value on the right half of the circle from negative pi over 2 to positive pi over 2, the only answer in that would be there. Okay, so the answer to that particular question would just be pi over 6. Suppose, however, that the question went further. What if it said from 0 to 2 pi? In that case, I just opened the door further. So one of the answers better be pi over 6. But is there another? What's the other? 5 pi over 6. Good. So I do think they should be a little bit more specific, because if you only want one answer, you better be kind of narrowing it down. Otherwise, there are gobs of answers to that question. There is something called a general solution. And that's where we try to describe all of them. But I'm not going to get into that right now. Okay? General solutions, these are called specific solutions. We'll get into general solutions later. And no, you do not have to salute them. Yeah, you did? Okay. All right, so tomorrow I can answer more questions for you. And Thursday we have one part of the test, and Friday the other part. And I hope you're ready.